And my goal here is to examine some of the local environmental and ecological patterns in Rhode Island that are associated with the recent warming event, which has been going on for several decades now. And first, we're going to jump right into these variables. This is air temperature in Rhode Island over the last century. And we see in the early part of the 20th century quite an increase, about of a degree, and then a leveling off in the 1950s and 60s. And then in the recent decades, from the 1970s up until the 2000s, another increase. But now we're about a degree higher than we were when we started in the early 20th century. So the climate here is warming. And this shows you how that pattern of warming happens over the seasons. In the dashed line there, we have the temperature pattern for 1890 to 1899, a 10-year period, January through December. And temperature is on the y-axis here. And you can see that the dashed line the small dashed line is always below the larger dashed line, which is the 10-year period from 1990 to 1999. So all seasons have increased in temperature. The annual increase is on the order of 1 degree centigrade or 2 degrees Fahrenheit. But we have a much larger increase here in the wintertime. And that's on the order of about 2 degrees centigrade or 4 degrees Fahrenheit. So winters are a lot warmer here now than they used to be. And there's a whole bunch of stuff here which we'll go through slowly. First of all, surface water temperature. Like the air temperature, it has increased since the 1960s to the early 2000s by about 1 degree. It's about 11 here and about 12 up here. So we're close to matching the air temperature with regard to the increase in the water temperature. In addition to that, the total precipitation has increased dramatically over the last century. At the beginning of the century, we were around 90 centimeters rainfall per year, and now we're up to about 120 centimeters of rainfall per year. That's a 25% increase in rain, so it's getting a lot wetter in Rhode Island. In addition to that, wind speed has been decreasing, and the decrease has occurred over much of the 20th century. I'm not too sure about these early data points, but I do trust these points back in the 1950s up through the year 2000. So wind speed, on average, has decreased by about 20%. So it's warmer, it's wetter, and it's less windy. And it's cloudier. From 1920 to the year 2000, we increased from 120 cloudy days per year to today when we have 180 cloudy days per year. So it's warmer, it's wetter, it's less windy, and it's cloudier. Ugh, huh?
Sounds like Seattle.
It does. So these are the things we're going to look at to see how they've changed over time between 1970s and 1990s, with particularly the winter water temperature increasing by about 2 degrees centigrade or 4 degrees Fahrenheit. First of all, winter flounder, which used to be the dominant fish in Narragansett Bay, has decreased drastically. And as the springs have warmed and the winters are warmer, the predators become active earlier in the year. So it's thought that Crangon shrimp, little sand shrimp, which Dave Taylor at Roger Williams did some work on under Jeremy Colley here, he showed that predation by Crangon on the eggs of winter flounder and the larvae of winter flounder could have a significant effect on their abundance. We've seen American lobster and other decapods increase in Rhode Island waters. Yay, that's a good thing. We have a signature event in the bay, which is the winter-spring diatom bloom, which used to happen every year between January and February. And as the winter has warmed, that bloom has failed to develop. So the pulse of organic matter that results from that bloom when the water is very cold, which goes to the bottom and feeds all the bottom animals there, the clams and the worms, etc., that no longer happens in some years. And that's sort of reverberating through the ecosystem. Eelgrass beds, after some recovery in the 1960s, again declined through those warm decades. of the latter part of the 20th century. We've seen a dramatic change in jellyfish cycle of abundance. Ctenophores become more abundant in early summer in contrast to the former high abundance in the fall. So their pattern of distribution has shifted to the early summer, and they have huge predation impacts on zooplankton in the bay. And I probably won't talk much about these other things, but oysters repopulated the bay in the 1990s, and as they grew up to adulthood, they were infested with this disease, dermo, which previous to this time had only been found as far north as Chesapeake Bay. So with the reoccurrence of oysters in the bay, we also brought diseases into the bay, which decimated the population, the wild population at least. I think aquaculture species are still doing fine. And we've seen some increases in more southern species like the smallmouth flounder in our fish catches. So let's take a look at some of the data on these things. We do a weekly trawl at Fox Island. It's under the direction of Jeremy Colley here. And that's been going on since the 1950s on the x-axis here all the way up till the present. And the numbers here are the mean monthly trawl catch for winter flounder. Here's a winter flounder. And here are the sand shrimp or crangon, which may have led to their decreasing numbers. In the 1960s, we'd had very high populations of winter flounder. We had a cold year in here and a very good year class, which lasted for several years of winter flounder. But recently, very, very, very low numbers. It's not our dominant fish in the bay anymore. And a lot of other more northern species of fish have also decreased. This is some of Jeremy Colley's work. He put this table together. Fish on the other side of this line have decreased here by 100%. Fish on the other side of this zero line up to here have increased by 100%. So this shows that cunner, longhorn sculpin, northern sea robin, tautog, windowpane flounder, winter flounder, silver hake have all decreased, and some of these species by more than 100%. On the other hand, we see increases in, well, weak fish a little bit. Scup, our striped sea robin, little skate, longfin squid, river herring, bluefish, four-pot flounder, butterfish, and all kinds of crabs. We've got 3 crabs on here, but all crabs have increased. So some of these by 100%. So these are totals per decade from the Narragansett Trawl Survey at Fox Island. And the blue bars here are northern sea robin, and the lobster in the yellow bars here. As the northern sea robin and other boreal fish species decrease, we see a very dramatic increase in lobsters. Very good. Here's another way of showing that data on sea robins in red dots now as percent of the total catch by year from 1959 up to 2001. You see sea robins going up and down and then suddenly dropping out of the picture. And as they drop out of the picture, these cancer crabs increase in abundance. So it looks like as demersal fish, boreal species that like cold conditions have left the bay, that ecosystem component in the bay has been replaced by crabs and lobsters and large decapods. So it's like a switch, and the biomass is almost comparable in that switch. The fish biomass that we used to have is now equivalent to the crab biomass and lobster biomass that we now have. So the winter-spring bloom, the huge signature event in the seasonal cycle of bay ecology. As the temperatures have gotten warmer over the years, the bloom intensity has decreased, and there have been several years where the bloom has failed altogether. It seems like any time the temperature gets above 3 degrees in January, February, March, that bloom is very much diminished or doesn't happen at all. And here's some pictures up at the top here of diatoms. Now, those are the species that dominate in this bloom period. And I won't leave out eelgrass We used to have eelgrass beds up in the Providence River bordering the shore. This is from a chart that was from 1865 and prior to sewage treatment plant input of nutrients to this region. So it used to be that eelgrass beds were found throughout Narragansett Bay, including the Providence River and Greenwich Bay and all the shores along the bay to the mouth. With increased nutrient input into the bay from sewage treatment plants, I think the Rhode Island Fields Point plant went online in the late 1990s, and lots of other plants around the bay now, probably about at least 15 are entering the bay. So there's a lot of nitrogen nutrients coming into the bay that didn't used to be there. And I showed you that the temperature of the bay has warmed, and that's a lethal combination for eelgrass. More nitrogen and warmer temperatures are lethal to eelgrass, so that now eelgrass beds in the bay are confined to the lower portions of the bay. And primarily in the lower East Passage, this pink line are eelgrass beds which are bordering Jamestown Island and the Newport region over here. And there are some eelgrass beds in the lower West Passage, the yellow color here. But the eelgrass prefers the East Passage, which is deeper and colder. It's communicating more directly with offshore waters. The net circulation is for water to come in the East Passage and then eventually go out the West Passage. So the East Passage is a little cooler than the West Passage. And you can see that the eelgrass beds extend more further to the north in the East Passage than they do in the West Passage. So eelgrass is now confined to the lower portions of the bay. Ctenophores used to be very abundant in the late summer and early fall. And as the temperatures in the bay have increased, they got an earlier growth start in the spring of the year, so that now they're in highest abundance in the early part of the summer. And they're terrific predators on zooplankton. So now they're maximally abundant when we have larval fish and copepods present in the water column. And so they're exerting a huge pressure on zooplankton and larval fish in the bay. And that is all summarized, I think, in the next slide. Yeah, okay. In a cold winter, we have a winter-spring bloom and lesser blooms in summer. In a warm winter, we don't have any winter-spring bloom. We have perhaps increased blooms in the summertime period. Nemiopsis used to be abundant in the late summer, early fall, and now it is abundant in the early summer. And as a consequence, copepods, which used to be super abundant throughout the summer period, are now pretty much decimated by the predation of those jellyfish, which probably has consequences for recruitment of larval fish stages. So, to summarize all this quickly, the annual temperature has increased about 1 degree centigrade or 2 degrees Fahrenheit. Rainfall has increased by about 25%. Cloudy days have increased by 20%. And wind speed has decreased by about 20% since the 1950s. New ecological patterns associated with warming in the Rhode Island waters are decreased northern bottom fish and increased decapods, including lobster. We've seen a failure of the winter-spring diatom bloom in the early part of the spring. We've seen eelgrass decline from most regions of the bay, and it's now only found in the lower part of the bay where the water temperatures are cooler. We also see changes in ctenophore jellyfish cycles, which has had huge consequences for our copepod populations in the bay.